Time always runs the same way, it never goes backwards. Now, we're aware of time because we notice that things happen one after another. Time is one of the great mysteries of the universe. We experience it as a constant, always moving forward, never stopping, never reversing. But what if that's not entirely true? What if time, under the right conditions, could move backward? What if scientists have actually observed negative time for the first time in history? The concept of time has fascinated physicists and philosophers alike for centuries, from the ancient Greeks contemplating the nature of existence to Albert Einstein's revolutionary theories of relativity. Our understanding of time has evolved dramatically. Yet, despite all our advances, time has remained stubbornly unidirectional, until now. Scientists working at the cutting edge of quantum physics have just made an astonishing discovery. They have observed what appears to be negative time. In other words, they have recorded instances where time effectively moved backward. This groundbreaking observation challenges everything we thought we knew about the nature of reality and could have profound implications for the future of physics, technology, and even our understanding of free will. But how is this possible? How can time reverse, and what does it mean for our everyday lives? To answer these questions, we need to delve into the strange and often mind-bending world of quantum mechanics. In classical physics, time is considered a one-way street. This idea is deeply connected to the second law of thermodynamics, which states that entropy, essentially, the measure of disorder in a system, always increases. This principle explains why a broken egg won't spontaneously reassemble or why a cup of coffee won't unmix once cream is poured in. These everyday experiences reinforce the idea that time only flows in one direction, forward. However, in the realm of quantum mechanics, things aren't so straightforward. Quantum mechanics describes the behavior of particles at the smallest scales, and at this level, the rules of physics behave in ways that defy common sense. Particles can exist in multiple states at once, can teleport across vast distances instantaneously, and now, apparently, can experience time moving backward. The experiment that led to this groundbreaking observation involved manipulating quantum systems in highly controlled environments. Researchers used ultra-cold atoms and precisely tuned laser pulses to create conditions where quantum particles exhibited behaviors that defied the usual forward progression of time. One of the key mechanisms behind this discovery is something known as quantum superposition. This principle states that a particle can exist in multiple states simultaneously until it is observed or measured. Researchers discovered that under certain conditions, these particles could be nudged into a state where their wave functions evolved in a way that mirrored the past rather than progressing toward the future. This reversal of the expected order of events is what scientists are calling negative time. To put it in simpler terms, imagine a game of billiards where you strike a cue ball, and instead of rolling forward, it retraces its path back to where it started. This is essentially what was observed at the quantum level, though in an even more bizarre and counterintuitive manner. One particularly stunning aspect of this discovery is its potential connection to time reversal. Symmetry in theoretical physics suggests that time reversal symmetry means the fundamental laws of physics should work the same way whether time moves forward or backward. In classical mechanics, we don't observe this happening in reality, but in quantum mechanics, time reversal symmetry has now been observed under very specific circumstances. This raises some profound questions. If time can be reversed at the quantum level, could this principle ever be applied to larger macroscopic systems? Could we, in theory, develop technology that allows us to manipulate time? While the implications are purely theoretical at this stage, the very observation of negative time is a step toward understanding what might be possible. One of the most fascinating applications of this discovery could be in the field of computing. Quantum computing already operates in ways that defy traditional logic, and the observation of negative time could open the door to new ways of processing information. If time can be manipulated in quantum systems, it could lead to advancements in error correction, computation speed, and even entirely new forms of data processing that are currently beyond our imagination. There are also potential implications for our understanding of causality, the relationship between cause and effect. In our everyday experience, causes always precede effects. You flip a light switch, and then the light turns on. But what if, in certain quantum systems, effects could precede causes? While this might sound like science fiction, researchers are now grappling with the possibility that negative time could challenge our fundamental assumptions about the sequence of events in reality. Beyond physics and technology, the discovery of negative time also raises philosophical and existential questions. If time is not strictly linear, does that mean that our past, present, and future are not as rigidly defined as we think? Could this open the door to a new interpretation of free will and determinism? If the future is not set in stone, could it be possible to influence events in ways we previously thought impossible? Of course, this discovery does not mean that we'll be building time machines anytime soon. The effects observed occur at an incredibly small scale, and translating these principles into real-world applications is a challenge that scientists are only beginning to explore. But just as quantum mechanics led to groundbreaking technologies like semiconductors, lasers, and MRI machines, the discovery of negative time could pave the way for future innovations that are currently beyond our comprehension. As research continues, physicists will be looking to refine their experiments, test new theories, and explore the limits of what negative time can reveal about the universe. The discovery is still in its infancy, and much remains to be understood. But one thing is certain: the observation of negative time is a paradigm-shifting moment in science. It challenges the way we think about reality and opens the door to possibilities that were once thought to be purely theoretical. So, what does all this mean for us? For now, it's a fascinating glimpse into the deeper workings of the universe. It's a reminder that our understanding of reality is far from complete and that new discoveries can rewrite the fundamental laws we thought were set in stone. As we continue to push the boundaries of physics, who knows what other astonishing revelations await. The universe is vast, mysterious, and full of surprises. Negative time is just one more example of how little we truly know and how much there is left to explore. The future of time itself may be far stranger than we ever imagined. For centuries, humans have been obsessed with understanding time. From ancient sundials to cutting-edge atomic clocks, we have measured it, studied it, and tried to grasp its true nature. But what if everything we thought we knew about time was wrong? What if time doesn't just move forward but also backward? It sounds like science fiction, but recent experiments have suggested that negative time, or time flowing in reverse, might be more than just a theory. Scientists have observed something that should be impossible: a system behaving as if time were moving backward. If confirmed, this discovery could rewrite our understanding of physics, reality, and even the fate of the universe itself. But what does it mean to observe negative time? Is this the key to time travel? Could it explain bizarre quantum phenomena? And most importantly, how could this change the way we perceive the past, present, and future? Let's break it all down. The arrow of time: why time moves forward. We experience time as a constant forward motion. We are born, we age, and eventually, we die. A glass shatters into pieces, but those pieces never reassemble into a glass. A cup of hot coffee cools down over time but never spontaneously reheats itself. This is known as the arrow of time, a concept in physics that explains why time always moves forward and not backward. The arrow of time is closely tied to entropy, which is the measure of disorder in a system. According to the second law of thermodynamics, the total entropy of a closed system always increases over time. This is why things tend to break apart rather than come together, and why heat flows from hot to cold rather than the other way around. Entropy provides a solid explanation for why time appears to move forward. But what if there were situations where entropy decreases instead of increasing? Could this mean that time can flow in reverse? For decades, physicists have debated this possibility. But now, for the first time in history, experiments have provided direct evidence of negative time. The groundbreaking experiment, reversing time in a quantum system. So how did scientists observe negative time? The answer lies in the bizarre world of quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales. Researchers at a leading quantum computing laboratory set up an experiment using a quantum computer, specifically, IBM's quantum processor. Quantum computers work by using qubits, which are like the quantum version of classical computer bits. But unlike normal bits that can be either 0 or 1, qubits can exist in a superposition of both states at the same time. The scientists created a simple quantum system and observed how it evolved over time. Normally, quantum systems tend to spread out and become more disordered, following the rules of entropy, just like an egg breaking or ice melting. But then something incredible happened. Using a carefully designed algorithm, the researchers applied a special operation to the system. In a normal quantum system, the state would continue evolving toward more disorder. But in this case, the system reversed its evolution, returning to a previous state, as if time had run backward. This was not a simple computer simulation or a trick. It was a real, measurable effect. The quantum system behaved as if time had rewound, violating everything we assume about the natural progression of time. The implications: did we just discover time reversal? The experiment suggests that under specific quantum conditions, time doesn't always move forward, it can also move in reverse. This raises some mind-blowing questions. Does this mean time travel is possible? Could we use this principle to build a time machine? And if time can flowing backward in quantum systems, could it also happen in larger systems, perhaps even in the real world? Negative time and quantum superposition. The idea of time moving backward is not entirely new. In fact, certain interpretations of quantum mechanics have hinted at this possibility for decades. One of the most famous examples is the Feynman-Stueckelberg interpretation, which suggests that antimatter particles are just regular particles moving backward in time. In other words, when a particle and its antiparticle annihilate each other, it could be interpreted as a single particle traveling forward in time, then backward in time, and then forward again. Similarly, quantum superposition allows particles to exist in multiple states at once, meaning they might not be bound by the same strict timeline as classical objects. Some researchers have proposed that at extremely small scales, time itself may be bidirectional, meaning it can move forward and backward simultaneously. This experiment may have finally provided direct evidence for this phenomenon, showing that under the right conditions, time reversal is possible at a quantum level. What about the grandfather paradox? If time can move backward, doesn't that open up the possibility of paradoxes? One of the most famous time travel paradoxes is the grandfather paradox, where a person travels back in time and prevents their own grandfather from meeting their grandmother, thus preventing their own birth. If they were never born, how did they travel back in time in the first place? While paradoxes like this make time travel seem impossible, the latest findings suggest that negative time in quantum systems doesn't necessarily allow for paradoxical events. Instead, it may point to a new way of understanding time, one where past and future influence each other in ways we don't yet fully understand. Could negative time explain dark matter and dark energy? Another exciting possibility is that negative time could help solve some of the biggest mysteries in physics, specifically, dark matter and dark energy. Dark matter is the invisible substance that makes up about 85% of the universe's total mass. Despite decades of research, scientists still don't know exactly what it is. Dark energy is even more mysterious. It's the unknown force that's causing the expansion of the universe to accelerate instead of slowing down. Some physicists have speculated that dark matter and dark energy might be linked to hidden dimensions of time, regions where time behaves differently than in our normal experience. If negative time exists in quantum systems, could it also exist on a cosmic scale? Could entire galaxies be moving backward in time relative to us? If so, our understanding of the universe would change completely. Could humans one day control time? The idea of manipulating time has fascinated humans for centuries, but until now, it has remained purely in the realm of science fiction. However, this experiment shows that under the right conditions, we may be able to control the flow of time at a quantum level. While this is still in its infancy, the potential applications are staggering. Ultra-fast computing. Quantum computers could one day use time-reversing processes to correct errors, making them vastly more powerful. Reversible medical processes. Could we use quantum time control to reverse cellular damage? This could have profound implications for aging and disease treatment. Time manipulation technology. If we can figure out how to scale up this effect, could we one day build machines that slow down, stop, or even reverse time? Time,